Now let's move to chain rule. Chain rule is like a function of a function. When there is a function in an existing function. For example, suppose y is a function of u. What this means is that if y is a function of u, I just want to give an instance. If y is a function of u, that means I'm saying like y is like 3u squared. This is a function of u now, and u itself is another function. It's a function of another variable. So in this, let's say u is a function of x. So that means I'm going to define u as a function of x. Let's say u is now 2x plus 3. So how do you now find your dy ds in this instance? You can see that there is a function inside a function. U is a function of u, and u itself is a function of another variable. So a function u is inside a function y, a function of y. A function of a function of x is inside a function of u. A function of x is inside a function of u. So that's it. So how do you find the dy ds? What you are going to do is that you find the derivative of y with respect to u, and then multiply the derivative of u with respect to x. So for y now, you see that y is the dependent variable and u is the independent variable here. You find the dy du. And then for this one, you see that u is the dependent variable here and x is the independent variable. So you differentiate this with respect to x, and then you differentiate this with respect to u. So when you do this, when you multiply it together, you eventually get dy ds. So look at the expression now. For chain rule, when you have a function of a function, the formula you're supposed to use is dy ds is equals to dy du times du ds. Just imagine if I want to cancel du and du, what's going to happen? What do you have left? You see that the equivalence is also dy ds. If you say du cancel du, you have dy ds left. So it means that you have not done anything that is not acceptable, because dy du times du ds eventually will give you what dy ds, and that's what you are trying to find. So this is the rule we'll be using for chain rule. We will treat like 2 examples on that chain rule, and then we can then move to product rule. Now let's quickly treat these 3 examples on that chain rule. So solution to example 1. For example 1, solution. For example 1, we have that our y is equals to 2x cubed plus 3x cubed. You will see that what is inside this bracket is a function of x, right? So you can represent this expression inside the bracket with another letter. So let's say let u equals to 2x cubed plus 3x, right? So the moment you represent u with 2x cubed plus 3x, what happens to y? Then y becomes u raised to the power of 3, isn't it? Y becomes u raised to the power of 3. As soon as y becomes raised to the power of 3, you differentiate y with respect to u using our general rule or power rule. Dy du will be equals to what? 3u squared. That's 3 times the coefficient of u raised to the power of u raised to the power of 3 minus 1. This will give us 3u squared. And then if you differentiate u with respect to x, you have du dx. So, and what would this become? 3 times 2 will become 6. So this one will be 6x squared. You remember how we do it? You multiply the power by the coefficient of x and then subtract 1 from the coefficient of x. So this one will become 6x squared, then plus, if you differentiate 3x, it's going to give us what? 3. So now with this now, you will now use your formula for chain rule. What's the formula for chain rule again? Formula for chain rule is dy formula for chain rule is dy dx is equals to what? Dy du times du dx, right? And eventually dy dx will give us what? Eventually dy dx will be equals to, what's our dy du? Our dy du is 3u squared times, what's our du ds? Our du ds is what? 6s squared plus 3. Remember that you already assigned u to be equals to what? 2s cubed plus 3s. So the next thing is you substitute the values of u into your final answer, and then this become 3 into bracket of 3 is bracket of 2s cubed plus 3x and 6s squared plus 3. So that's that. Now let's move to example 2. Example 2, our y is equals to sine square x. Sine square x can also be written as what? Sine x all squared. Sine x all squared. So you can say y is equals to sine x all squared. Let your u be equals to what? Sine x. So when your u becomes sine x, what happens to your y? Your y becomes u squared. So when you differentiate u with respect to x using the standard derivative of trigonometric function, your du ds will become cos x, and your dy du will be what? 2u. Remember that your dy ds is equals to dy du times du dx, dy du times du dx, and then you have cos x times 2u. So this will give us 2u cos x. Remember that your u is what? Is sin x. So what do you have? You now have 2 sin x cos x. Don't mind me. My u looks like my u looks very well like x. This one is cos u, not x, please. Cos u. I mean, this one is cos x rather, and this one is u, cos x and u. So let me write. I think I already tampered with the x. So this is cos x. So I'm supposed to adjust the u so that it looks better. You will not be confusing u with x. This is 2u and this is cos x. This is also cos x. Are we clear now? So this is cos x times 2u. 2u cos x. My u is what? Sin x. So your answer is 2 sin x cos x. I hope that is cleared. I just hope that you can see the solutions clearly. Okay, let's move to the third example. So now if you look at the third example, you will see the whole of this expression. You can say let the whole of this expression be equals to what? U. Let u equals to x raised to the power of 5 minus 3x cubed plus 4x. And let y. So anywhere you see x raised to the power of 5 minus 3x cubed plus 4x, you replace it with what? With u. And this become cos u. So if you find the derivatives of cos u, you see that it's going to give you minus sine u. And then if you differentiate u with respect to x, what do you have? You have 5x raised to the power of 4 minus 9x raised to the power of 2 plus 4. So dy dx, which is equals to dy dx, which is equals to dy d times du dx. So, sin u times 5 raised to the power of x raised to the power of 5x raised to the power of 4 minus 9x squared plus 4. So you can say that 5x raised to the power of 4 minus 9x squared plus 4 all into bracket of minus, this sign as minus already, this function has minus, so you can put the minus here. Then your sign, instead of writing sign you just write what you have defined your u to be, and your u is what, x raised to the power of 5 minus 3x cube and plus 4x, and that calls for the end of that solution. So I think we are good to go on chain rule now. We've been able to do 3 good examples, so please check for more examples at your end. You can check your textbook, you can check online to perfect your understanding on chain rule. But I assure you that it's a direct method. If you follow the videos accordingly and you practice more questions, it will be more easier for you than you have that it will be more easier for you than you think. So now let's go to product rule.